Welcome to our Energy Portfolio Report. This is team number 3, Shaker Bascaron and Brenda Ventura. We hope to show through diagrams and charts the new resources, the old resources, and our recommendation for 20 years down the road. Here is the graph from our books showing the 2013 U.S. energy consumption by energy source. If you'll notice from the pie chart, we are very heavy on fossil fuels, natural gas and oil. The most used fuel in the United States are the non-renewable sources such as natural gas, oil, and coal. This type of usage is non-sustainable because there will be an ending point at some time. And it's interesting to note that the renewable sources are less than 30% of the total usage. We'd like to show the reasons that this is not a good model for going forward, and we would also like to make our recommendations for what this particular pie chart should look like in 2033.
In this segment of our presentation, I will discuss the negative effects that burning coal has on our environment. Burning coal emits a lot of toxins into our air, which creates pollution and smog and lowers our air quality. Coal is used to generate energy, but it also takes a major toll on our environment. The toxins that get emitted into our air are carbon dioxide, sulfur dioxide, nitrogen oxide, and amongst many others. All these toxins create smog, acid rain, and toxins in our environment in general. There have been numerous reports of respiratory and cardiovascular health issues due to the pollutants that burning coal puts into our air. Not only those issues we are coming across, but also the ash generated from burning coal is highly toxic and has to be disposed of in a hazardous waste disposal site. It just can't be tossed aside. That's pretty scary stuff. In this segment of our presentation, I will discuss the negative effects of nuclear energy. Just the word nuclear is pretty scary. And as you can imagine, nuclear does not have an environmental impact that is desired. The process of mining and refining uranium isn't very clean, and when transporting nuclear fuel from one plant to another, it creates a pollution hazard. Not only that, but once the fuel is used, you can't just take it to a landfill and dump it. It has to be disposed of properly. Nuclear waste transmits radiation in high temperatures, and whatever is holding it will eventually disintegrate. Also, any living organism, plants, animals that are in or around the nuclear plants will be affected. Next, we'll talk about the nuclear accidents. Nuclear accidents happen. Yes, we do everything we can in our power to avoid them, but like in life, accidents do happen. The most popular accident that has happened is the accident in Chernobyl back in 1986. It took a lot of lives when that accident happened. Its harmful effects on humans and ecology can still be seen today. Also, with the most recent tsunami in Japan, the nuclear power plants there were leaking into the ocean, causing negative effects on the environment and in Japan in general. Next, we will discuss the negative aspects of generating energy using oil. Oil is not an unlimited resource. It is actually fairly limited, and if we're not careful, we could run out of oil in the next 54 years. Yeah, 54 years sounds like a long time, but in the grand scheme of things, it's not very long at all. The United States uses 1/5 of the world's oil, but other nations are catching up pretty quickly. China and India are using more and more oil to create more of a demand. When drilling for oil, it could negatively affect our marine and ocean life in our waters. Um, Fish and marine mammals could be harmed or even killed when drilling for oil. And if we are drilling for oil on land, vegetation areas may be taken away or disposed of in order to drill for oil, which is not good in any case. Next, we will discuss the negatives of using oil to generate energy. One of the biggest negatives is that oil is not an unlimited resource. It is fairly limited. And with calculations of the RP ratio, reserve to production ratio, it is estimated that we will run out of oil within 54 years. 54 years does sound like a long time, but in the grand scheme of things, it's not very long at all. The United States consumes 1/5 of the world's oil, but other countries are rapidly catching up. China and India are increasingly driving the world demand for oil. One other issue that we have to be concerned with is oil spills, whether that be from ships or refineries. It needs to be taken into account. Obviously, we do everything in our power to make sure that oil spills don't happen, but as we've seen previously, they do. BP, with their infamous oil spill that caused extreme measures in our environment, in our oceans, and even killing wildlife. We also got to be careful when drilling for oil. When we drill in the ocean, we run the risk of harming, possibly even killing our fish and marine mammals. And also, drilling on land usually requires the vegetation fields to be eliminated due to drilling. So we need to make sure that we are using other resources and not using oil so heavily because one, we could run out, and two, it is hurting our environment and our animals that live in our environment. Next, we're going to discuss the negative effects that natural gas has on our environment. Natural gas is actually one of the safer and healthier ways for our environment to generate energy, but just like all the others, it does have some negative effects. Drilling and extracting natural gas could result in leakage of methane. Also, the transportation of natural gas could also result in leakage of methane, which creates air pollution. Natural gas releases carbon dioxide, which is linked to major health issues and major health concerns. Some of those problems are asthma, bronchitis, lung cancer, heart disease, and hundreds of other Americans have had negative effects due to the pollution that natural gas puts into our air. The exposure of the air pollutants obviously is not good and creates health issues for people who are around it. Not only people are affected, but also wildlife and the environment in general.
One of the more positive sources of energy consumption is hydropower. There's many reasons that this is a really good energy source. The first thing is that it is clean. It comes from flowing water, no matter the type. And most of the time, our flowing water in at least the U.S. is somewhat clean. And for this type of power to work, it does have to be clean flowing water. So that does give some incentive for keeping everything, clean and workable. There are three types of hydropower. The most common of these are the storage techniques. That's where you've got the big dams with the water behind them and they go through turbines, and that's the one we're most familiar with. The second one is the run of river technique. It's kind of like in the old days when they used to have like grist mills where they would, run a river through a building, kind of reroute it and come back to the water. That would not only, power their grain producing facilities, but it also created an excess of power in most of our communities. back in the day were actually powered by the run-of-river technique. It is still a possibility today, and there are still communities that use that. But it to be sustainable and affordable, it really has to be done on a larger level than just a small river. The third and most inconsequential, at least in our terms of energy production, is pumped storage. It's pumped from a lower reservoir to a higher reservoir during times when the demand for power is weak. And then it just runs everything through. It is a very recyclable way to process the energy because you're basically just rerunning the same water. However, it is not feasible on a very long-term, large basis. The next renewable power source is bioenergy. This is a very interesting type of energy source and one that I believe is very unused in this country. And I think part of the reason is it's gotten kind of a bad rap. Most people think of bioenergy as burning, burning waste products, burning organic materials, wood, charcoal, that kind of thing. That is part of it, but it's not the whole story. Bioenergy is something that consists of organic materials, living or recently living organisms, which contains chemical energy, which actually originated with the photosynthesis from the sun, which brought carbon into the biomass material. There are quite a few bioenergy sources that do not rely on burning of the organic material. There's biofuels, corn, sugarcane residue, soy, soy, soybeans, um, and cooking oil. They are all used for ethanol and biodiesel. They're also looking at new ways to retrieve plant matter that's been left over from harvests. It produces cellulose ethanol, which is just as valuable as the original ethanol made by the first crop, which would be the corn. They also grow some types of algae for biofuels. That's not quite as prevalent these days. They also are starting to use forestry residues. Now, that is definitely something that they would burn. But the interesting thing about bioenergy and the carbon produced from burning it, it's actually a wash because the fact that it originally started with photosynthesis, they actually pulled that amount of carbon from the atmosphere to create the plant. So the burning carbon that creates the energy actually cancels out the carbon footprint of the organic material. We see this as a very good thing. It pretty much brings the carbon footprint down to zero. That brings us to the newest renewable sources of solar, wind, geothermal, and ocean water. Interestingly enough, renewable sources only, as you saw in the graph, take up about 20% of our consumption, while most of that, about 13% of that, is biomass and hydropower. The rest comes from these very minor sources that actually could be much better. It looks like solar energy only accounted for 3%, geothermal for 3%, wind power for 15%, ocean power, that's along the lines of the geothermal energy, and that's included in that percentage. The interesting thing about this is that, this is all renewable. It's all something that happens every day. I just believe that it's not accessible, and that's why we're asking for more funding for expanding these types of energy, and we do believe that this little portion of the renewable energy scale should be actually almost outweighing biomass, or at least being equal. So why should we spend all this time, money, and effort trying to explore these newer renewable sources? Well, there's a lot of good reasons. We do need to focus on the renewable versus the depletion type of sources. That will end eventually. And if we can actually take steps now to focus more on renewable energy, those resources will last a whole lot longer. This will also allow us to be less dependent on foreign sources for fossil fuels. If most of our consumption is based on fossil fuels that, yes, some come from our country, but most come from foreign oil sources, we are dependent on them for the running of our country. In the end, after the research and um, experimentation and implementation has gone away, it will eventually be less costly down the road because they are pretty much self-contained systems. They do need to be monitored, but this is something that happens every day, and this is something that would be, once it gets going, would be an unending source of renewable energy. And frankly, we just really haven't been great stewards of our non-renewable resources here in our country. So I think we should feel a responsibility to be better stewards because we do have untapped potential. We do have untapped oil resources in this country. Do we want to be completely dependent on foreign oil and, possibly have services shut down because we can't afford it? Or do we want to be the country that has these reserves left over when maybe no one else has them? It's something to ask, and it's also just better for our planet and better for our country. And on that note, this could actually make us an example to developing countries on energy uses rather than being the example right now of, depleting our energy sources too much. So based on everything that we've said, the next slide will show our recommendations for 2033. So based on the material that we've presented, we sat down and figured out our recommendations for energy use going forward. We feel that we should increase the hydropower from 2.8% to 20%. The reason for this is that there are so many waterways and so many untapped resources that could really be used with one of the three methods to better supplement our electricity supply. We are moving into more of an electronic age, and we are going to need that type of power. We do believe that bioenergy does need to be increased from 4.5% to 10%. Bioenergy actually might even be something that would be increased even more than that because once everything gets in place and people understand it's not just about creating carbon and smoke and bad for the environment, they may understand that this is a very, very sustainable and renewable source of power. The new renewables, we believe that should go from 1.9% to 10%. This will cost money and this will require funding from many sources to get on the ground. But we've already seen many breakthroughs in wind power and solar power. It's just a matter of getting it to be an affordable alternative for the everyday consumer. We believe that the nuclear energy sources must be reduced. Now, this is something that's a smaller reduction from 8.5% to 5%, because there are countries that do rely very heavily on nuclear power at this moment, and 20 years is really not enough time for them to reduce it as much as perhaps we may feel that they need to. Coal, a very, very dirty and unrenewable resource, um, should go down from 18.3% to 5%. And while they still kind of fall under that rule of carbon versus carbon, it does not actually compute as well as the biomass. Natural gas, we feel that that should go down from 27.3% to 25%. While those are depletable resources, it is a very clean source of energy and a very efficient source of energy. Finally, to oil sources, we believe that that should go from 36.5% down to 25%. Fossil fuel, as much as we can be unreliant on fossil fuels, is better. However, we realize that there is major industries and, our cars and things like that that are going to rely on oil type of production, at least for some time. Now, as the new sources come into play, that may reduce even more than 25%, but for now, we feel that that's a reasonable reduction. As you can see by the side-by-side comparison from 2013 to 2033, the first thing you notice is that the chart is much more balanced. And in that balance, as we go to more sustainable, renewable energy sources, that will eventually be less costly. We do believe that it is an attainable goal because we're not trying to just shut off everything. And that always leaves room for improvement. So down the road in 2053, I'm sure we're going to see a much different pie chart emerge. Thank you very much for your time. We hope you've enjoyed our presentation.